Good foliage assets often rely on various textures and mesh pieces for complexity, believability, and visual appeal. In this video, we'll look at the Sprout Mesh Builder, where you can render texture atlases, or work with existing ones, to then generate and organize the many mesh elements you'll need when making your assets. The MeshBuilder editor is built around the MeshBuilder Actor, which we can see here. This acts as a staging area for creating meshes from a texture atlas, editing their UVs, managing their LODs, and we'll also see later on that it is useful for rendering our own atlases. We'll start by loading in an atlas material using the Details panel. We can see that the Mesh Builder in the Outliner tab already has a Mesh Actor child with no mesh data, so let's start building. There are a number of tools that we can use to create our mesh, which we can see in the Mesh Builder Mode panel here. We can switch between these tools by clicking or by using the num keys. Each tool has a description, and some have properties that can be edited to affect their behavior. We'll start with the Context Create tool, which combines many of the other tools' functionality. We can Control-click on the backdrop to begin adding vertices. We can also quickly bridge edges. We'll switch to the Split Edges tool to add vertices to existing edges. And we can transform any selected elements using the Transform widget. We can control the visibility of mesh elements using the Show menu on the Viewport toolbar, and whether or not those elements can be selected using the Select menu. Notice that there are extra buttons on the toolbar for doing so as well. To edit the pivot of our mesh, we can show it through the Show menu or by pressing P. It can then be selected and transformed like any other mesh element. We can also snap it to the current widget transform from the Mesh Builder panel or by pressing Shift-P. To add an LOD to our mesh, we can go to the Manage section of the Mesh Builder Mode panel and click Add LOD. This will make a copy of the current LOD. Notice that the LOD menu in the Viewport toolbar has been updated. We'll make some edits to simplify the mesh for LOD 1. We can now use the toolbar menu to switch between LODs for this mesh. We can also edit the UVs of our mesh. Currently the UVs are being auto-generated based on a vertex's position in the frame. We can disable Auto UV by clicking the button in the Viewport toolbar. Now we can edit the UVs of the mesh by transforming its UV elements. We can re-enable Auto UV at any time, and the UVs will be updated when the mesh is next edited. Lastly, we'll look at the Add Socket tool, which allows us to click and drag to interactively create sockets. We can use the tool properties to change the name that the sockets are created with. We can edit any created sockets using the Socket Manager tab, which will update when we select a socket. We can change its name, and we can edit its transform from here. We can also edit multiple sockets at the same time, changing their names and their transforms. To create new meshes for our atlas, we'll go to the Outliner and click the plus button to the right of the Mesh Builder. This will create and select the new mesh so that we can start building as we did with the first. We can now switch between meshes by clicking them in the viewport or by using the Outliner. It's best to rename these since each mesh will be identified by name when using this Mesh Builder asset in other sprouts. The Mesh Builder editor can also be used to render new texture atlases. We'll create a new Mesh Builder to act as our frame, and we'll unhide our render elements. If we focus on the Texture Preview tab, we can see our current render target updating in real time as we edit the scene. We could edit this sprout by opening the Sprout editor, but we can also activate the Sprout Edit mode in this viewport by clicking the Toggle Mode button in the Editor toolbar. This will update the Mode tab with all of our Sprout Edit Mode tools, and we're now able to open up any Edit Mode specific windows. If we open the Sprout stack, we can edit this sprout and see it updating in the Texture Preview tab. For this demo, we'll build our atlas using a template we created earlier. In the Details panel, we can edit any of the variables we had exposed on our sprout. We can duplicate the sprout by Alt-dragging. This lets us quickly create variants for our atlas. When we're satisfied with our atlas, we can use the Texture Preview tab to preview our texture outputs. Using this drop-down, we can cycle through our available textures. We can also look through the composited textures that we've set up. These output textures are configured through the Texture Capture's Details panel in the Baking category. If we expand Textures to Bake, we see our named outputs, which specify which textures we want to use in each channel, along with some other options. These changes are reflected live in the Texture Preview tab. Now, we'll render these textures using the Render button in the Editor toolbar. The Texture Previewer updates to show us our created textures, and we can also access them through the Texture Capture's Details in the Output category under Results. If we double-click on any of the textures in the Texture Previewer, we can see it isolated. We can return to the multi-texture view by clicking on the toolbar button here. If we want to go back to live capture mode, we can click this lightning bolt button. We can add elements from existing atlases as well. Returning to the outliner, we'll duplicate one of the meshes we created earlier and drag it into the frame. Switching back to the Texture Preview tab, we see that the leaf is not showing up. By default, the Texture Capture only shows sprouts. Instead, we can change this by going to the MeshBuilder Mode panel and under the Rendering section, clicking the Toggle Render Elements button. Now when we render, this leaf will be included in our atlas. Once we've finished creating mesh actors for our atlas, we can begin to assemble clusters. The first step we'll take is to create a linked mesh. In our outliner, we'll right-click our large leaf card and select Add Linked Mesh. Now that we have this, we'll transform it into view. Since this copy is linked, any changes we make to the source mesh will be applied to the copy. To turn this into a cluster, we simply unparent it from its mesh builder by dragging it into empty space on the outliner. This creates a new group actor with an LOD child and our linked mesh as a child of the LOD. We can also create group actors through the Manage section of the MeshBuilder Mode tab. We can duplicate the linked leaf mesh to add another to the group. We can add other elements from our builder as well. We can make arranging these leaf cards easier by enabling socket snapping, using the magnet icon in the viewport toolbar. Now when we edit the transform, the meshes snap to any sockets that were added to the source mesh. These mesh elements can be parented to each other as well, so that when one is transformed, the children follow. In this way, we can build up complex clusters quickly. To add another LOD to this group, we can press the plus button in the outliner. We'll duplicate these mesh elements, drag them into our new LOD, and make some changes. It's often useful to transform the LOD actors to make them easier to work with, but this transform offset will not be applied in the final mesh. The cluster we've created will be exposed through the MeshBuilder asset, but we can also click the Make Static Mesh button in the Editor toolbar to save it as a StaticMesh asset. We'll open the asset now, see our mesh, its LODs, and all of its sockets.